Good afternoon. Welcome to Dev 107, Building Emotionally Available XPage Applications. As you saw in the last slide, my name is Mike Smith, and I work for a company named Mutual Boiler Re. I've been developing Domino applications for a long time, probably half of which has been focusing on XPages. I'm very fortunate to have been an HCL ambassador for 2021 and now 2022. I've presented at CollabSphere multiple times, a couple times in person, and now a few times virtually as well. And I do occasionally blog at xpage.me and tweet at Michael G. Smith. So what exactly do we mean by emotionally available XPage applications? All it means is we just want our applications to work when we expect them to work. And we want them to be highly available. And our users want our applications to be highly available. If we look at the definition of high availability in Wikipedia, it refers to a particular service being available. And high availability is a negotiated level of uptime that is higher than normal. The word cloud in this slide kind of illustrates some of the things that we associate with high availability. Load balancing, redundancy, and failover. One of the technologies that has essentially become synonymous with high availability is reverse proxy. And this slide demonstrates a couple of different types of reverse proxies that are out there. But just to be clear, this session is not about how to set up and configure a reverse proxy. There have been other sessions on that in the past in CollabSphere, and there's just tons of resources online for doing that. What I do want to focus on in this session is how to develop XPage applications to work with a reverse proxy. So what is happening in front of the reverse proxy, what's happening behind the reverse proxy, and the tools that are available in Domino Designer today to help build XPage applications that will function in HA environments. And if we have time, we'll get to some bonus topics as well. When it comes to high availability with what I call classic XPages, classic XPages don't work very well in high availability environments. And what do I mean by classic XPages? Well, when we first started developing with XPages, we would have a document data source, do a lot of partial refreshes of certain parts of the screen, use scope variables. And there was a big reliance on maintaining the state of the page on the server. So you're making a partial refresh. The server has a version of the page in memory. It makes, whatever updates need to happen on the server and sends back the part of the screen that you requested. And ultimately, your pages can also expire unless you're using the keep alive control, for example. So what happens with a classic XPage application when the server goes down? Well, for starters, you're going to lose your page state, or the states of any pages that are in memory, any scope variables. What you end up with is angry users. And you can't tell your users, well, just refresh the page and you'll get everything back, because there's the potential for lost work there. And in our environment, any time lost to server disruptions is taken very seriously, to the point where our users actually track their time that they're down. Something we hear a lot these days and for the last few years is, well, why not just migrate to a different platform? Well, if you're heavily invested in Domino, your data's in Domino, you have a lot of data in Domino like we do, your business logic is already in Domino, and the skill set of your team is also deeply invested in the Domino stack. And then finally, if you've spent a lot of time building your enterprise applications, Your management team might not always have the appetite with time and money to just transition that to another platform, and we've all seen that it's just not that easy to do it. So let's take a quick look at a demo that demonstrates a classic XPage in a high availability environment. So what I have set up are two Domino servers that are behind an Nginx reverse proxy, such that if I'm connected to one server and that server goes down, the reverse proxy is automatically going to reroute subsequent requests to the other server. So let's take a look at what happens. What I have here is what I would call a typical XPage. There's a couple different panels on here that hide and show depending on clicking the next button, previous button. There's a couple drop downs on here. This drop down is populated in a typical way with a DB lookup to a data source. And then this model drop down populates depending on making a selection in the make drop down. So as you can see here, I'm now getting some values. So looking at the source of this, again, fairly typical. Here's the drop down on change event. Does a partial refresh down here. The actual code, fairly simple. I'm using the application scope to create a little bit of a cache. And the model drop down is populated in a similar way. Let's see what happens to this classic XPage when I turn off HTTP on the primary server here. So I've got the page reloaded. I can move back and forth, but I'm going to flip over here to the admin client. And I'm turning off HTTP. Okay, back to my browser. Now remember, when I select a make here, I'm expecting the model drop down to update based on whatever I choose here. So I'm going to choose Chevrolet again. And you can see I get nothing. And we get an error message. We get a runtime error, because the new server is not able to locate anything in memory for this particular page. Now I can go ahead and refresh this page, and it's going to reload and put me onto the other server. And I know that because I have a little meta tag here, and it tells me which server I'm on. So the primary server is MGS2. I'm now on MGS1, so that's how I know that it's definitely flipping me over to the other server. So now that we have that done, I'm going to turn HTTP back on. Flip back. And now when I refresh, it has put me back onto the primary server. I realize that's a little backwards. The primary server is 2, and the backup server is 1. But that's just the way it is. So what this little demo showed us is that in any instance where our page is relying on the server to maintain some sort of state, and we're in a high availability environment, and the server we're working on goes down and other requests go to another server, everything is going to blow up. So the question is, how do we develop around these constraints? Well, it starts by separating the front end and the back end and building applications so that there is not this reliance on one piece always relying on the other. They really should be interdependent, and the front end should be able to submit a request to the back end and not really care which server it hits. And on the flip side of that is the back end shouldn't really care where it's getting its request from. All it needs to know is what is being asked of it, package up that request, and send back whatever information it's supposed to send back. So what that really means is we want to start developing using a microservice-oriented approach. If we look at the left side of the slide here, this is illustrating monolithic architecture, and XPages is not technically monolithic. I feel like it's a hybrid of single page application along with monolithic. Going back to the demo we just looked at, if the server goes down, the application goes down. So that makes it kind of feel monolithic in that sense. So the idea is to focus on microservices. Microservices don't rely on maintaining a state. Microservices, it's easier for teams to focus on their specific part of the application. It's easier for front-end developers to focus on the front end and for back-end developers to focus on the back end. And in the XPages world, we've all been essentially full-stack developers. And sometimes when you have multiple people working on a project, it can seem like too many cooks in the kitchen. On this slide showing several of the popular front-end frameworks, certainly not comprehensive in any way, but certainly names you're going to be familiar with. All of these technologies rely on a microservice-oriented approach. If it's making a request for data, it's just pointing to a URL, and it's expecting to get data back. It's not expecting there to be an issue of the endpoint that they're pointing to maintaining some sort of state. It's a request, and they want to get data back. So if you want to start taking a microservice-oriented approach with your XPage applications, XPages has controls right out of the box that can help you do that. And to be clear, I don't want to give the impression that I've discovered these concepts and I'm now unveiling them to the world. I'm just reinforcing their relevancy within the Domino landscape to build modern applications. Okay, well, what about the front end then? Well, when you're building your XPage, by all means, use the server-side processing engine to get that page loaded the way you need it to be loaded. Start layering on different front-end frameworks and libraries to enhance your app. Me personally, I use a lot of Bootstrap and jQuery. It's become almost like second nature and muscle memory for me to add them to applications at this point. And the last point here is, the important thing is to not rely on server state. Build your application so that you're making a request to a server, and the server really the only thing it needs to know is the information that you are passing it. Now, maybe once the server gets the information, obviously it's going to have to retrieve information based on that request. But the important thing is to not rely on that server maintaining a state for you. But just to be clear, when I say state, I'm referring to the state that is built into XPages. I do think there are opportunities for us to build our own state that is more high availability friendly, and hopefully I can get into that at the end of this session or blog about it in the future, but I do have some proof of concepts around that. The first control I want to take a look at here is the remote service, also called RPC for remote procedure call. And this is available in your data access palette, and you just simply drag it onto your XPage. We're going to take a look at a demo in a moment that illustrates the RPC control. But at first, I just wanted to look at some of the configuration parameters. So most importantly is the service name at the bottom of this slide. This is how you invoke the RPC control. And then within the control, you have all of your specific methods that go with this control. And the name parameter is how you're going to invoke this particular method in your client-side script. And under the script parameter, this is where your server-side code is going to live. In my case, I'm pointing to a server-side JavaScript script library. Also, very important, the arguments that you configure for your method must match the arguments that you're going to pass in to your server-side script. With our control now on the page, let's take a look at the code that we're going to use to invoke the control and the code that's going to be on the back end to process the request and what that's going to send back to the front end. So as you can see at line 58 here on the left side in the client side section, we're invoking the control using RPC car. So again, that is the service name of our control. And the method I'm calling is getModels. And I'm passing a string to that, which is the value from the make field. A quick note, something that I find very beneficial with using this control is I don't have to pass a string or a number. I can actually pass a JSON object, and I do not have to stringify that JSON object. I can just pass a JSON object to the back end and process that on the back end as an object. Let's take a look at the server-side code now. So we're calling a server-side JavaScript function getModels. And also, I guess it's important to note that the front-end method name and the back-end method name do not have to match. That just happens to be the way that I like to do it. It kind of feels intuitive to me to do it that way, but they do not have to match. So as we're taking a look at our server-side code here, so it's just like, again, a standard server-side JavaScript function, and we are returning an object. And it's also important to note that whatever you return from your server-side script, Domino is going to automatically put that in an object. So if you are returning an object, Domino is going to take your object and put it into another object. And we'll see that in play here in a couple minutes. I want to flip back over to the client side now because we invoked the control, we made a request to the back end, we handled that request on the back end, and now when the response comes back to the front end, we have to handle that response in some way. So that's why on line 58, we have the add callback here. So the function that we put inside of the callback is how we're going to process whatever we get back from the server. In the case of this example, I am dynamically rebuilding the model dropdown based on the value that was selected in the make dropdown. Oh, and one more important thing about our server-side script. So you can see in the little bubble there that it says it must return a value. And if your script does not return a value, then you're going to get an error in your AJAX request. So just important to keep that in mind. Okay, let's take a look at a demo that is using RPC calls to interact with the server. So here is our RPC demo. As you can see, the screen looks very similar to the way the classic demo looked. Switching back to that, now back to the RPC. One difference here at the bottom is as I load different panels, just a little more of a modern look to it with the dots. But an interesting thing to note about this is as I click these dots down here, to move to different screens within the same page, the HTML on those other screens are actually loaded dynamically through an RPC call, and we'll look at the code that does that here in a moment. The make dropdown is built dynamically when the page loads. And again, if I make a selection here, my model dropdown is built dynamically as well. Something else I want to point out about this is, as I've had this page open sometimes for days at a time, closing my laptop, opening it, as I've been working on this presentation, the page has never stopped working. So in contrast to a classic XPage where the page expires, or some of the other different things that might happen as I've taken servers up and down, this page has never stopped working. So it's a microservice oriented approach, and it just works. Let's run the same test that we did on the classic XPage. I'm going to refresh this, and now again, when I select a make here, the model dropdown gets populated dynamically by making a request to the server using RPC to get all of the models for that particular make. So I'm going to take HTTP down again. It's down. Now, something to keep in mind here, you can see that there's kind of like just a hair of a delay there. And, I guess if I was making a production application, I would have an indicator in the model field to let the user know that something is happening there. Because this page has to be loaded on the new server, and there might be a slight delay with the reverse proxy as well. But you can see we made a request to a different server because we turned off HTTP on the main server, and we still got values here. So now the next thing we're going to do is click over to different screens here. Same thing, a little bit of a delay, but all of this data is being loaded. All of this source is being loaded dynamically. Now let's take a look at the events that are driving all of this. So we have this XPage here, our car XPages RPC. The first thing I want to draw your attention to is the script block down here. So inside of this script block is simply just an init function, which is in our car object, which contains an RPC object, which is client-side JavaScript, of course, because it's a script block. So take a look at this. What this init function is doing is, first thing it's doing, it's going out and getting all of the makes to populate the make dropdown. And then it's trying to get data. So we're looking at a new document right now. If this was an existing document, it would try to populate the data for that document. And the final thing here is a method to initialize all of the different events on the page. One of which is the onChange event for the make dropdown. So you can see we are binding that, and we are calling get models on that change event. And what that function contains is the RPC call. So let's take a look back at the XPage, and we have our get models RPC call. So you see we've passed in a variable here. We're passing in the make, making a call to the back end, and that back end call is car.document.getModels, and here is our variable. If we bounce over to the server side script, here's our getModels function. And this bit here, excuse me, this bit is actually retrieving all of the models for all of the makes. And you can see the first time this call gets made, all of the models for all of the makes are getting stored in an application scope. And so then subsequent calls we're retrieving from memory instead of disk. And down here, we're actually looping through those values and getting only the models for the make that we passed in. And then finally, we are sending our response back. I always, as I said before, XPages and Domino, it's always going to send back an object. So I create an object, so it ends up sending back an object inside of an object. That's just the way I prefer to do it, because that way it's easier for me to do error handling in the front end, because I can send a success status or an error status. I'm also sending the server back here so that, we'll see in a minute that we can see where the request is coming from. So we'll turn off HTTP again in a minute and take a look at that. Let's take a look at these requests again. Let's do it through the eyes of DevTools. So refresh the page. So the first thing we see here is the RPC call that goes and gets the makes. Here's our results. So Domino is always going to have the result object. And again, my object is in data. And you can see here's our server and our status of success. Something else I want to point out real quick is in the callback for this. So here's our callback, how we're handling that request. And you can see we have RESP here for response. This is what I'm calling the response that's coming back from the server. So you can see that they send it back in result, but the value that you enter here is where you're going to read the data from. So you can see down here if status is success, and then now we are building the make drop down. Okay, so now if I choose something, here's another request. And now we're getting the models for Chevrolet. Again, server, status, success. So let's do this again. But let's turn off HTTP. So now when we choose make, we're going to interrogate that request and see what the server says. See, now we have switched over to the other server. Let's also take a look at the RPC call for switching screens here. So again, I have my dots down here, which signify 3 different screens. And when I click the second dot, it's going to make a request using RPC to get the HTML for that screen. Here's my call down here. So you'll notice in this particular call that I actually did not put my server response in an object. So you can see here, the content is loaded directly into the result object that is automatically created by Domino. So we just take a quick look at this. So that is it's actually what is that? Let's look at the events. So RPC events, here we go, dot style, car.rpc.getPage. Here's that function. Here's the RPC call. We're passing a screen value, basically telling it the HTML for which page to retrieve. Our callback, again, we're using the RESP variable, and we're just reading that directly. Here's the server-side piece of that. So back on our XPage, for that particular method, we're actually on the server side calling, we have a wizard object inside of the car object and a getPage function, which is here. And you can see this is fairly simple and rudimentary, just a DB lookup to a view. And within that, it's just pulling data out of a notes document. So just HTML stored in a document, dynamically loading that into the page. Now let's take a look at loading an existing document. So I happen to have one queued up here. You can see all my data loads. If you remember, when this was a create document or a new document, there was only one request here. Now we have two. So we have a second request that contains all of the data for this particular document. Let's take a quick look at the round trip that is occurring here. So if we come back and take a look at our init function, so we're getting the data, get data, and here's where we make the RPC call to the server, and we're grabbing the doc ID out of the URL and passing that to the back end. Now in the back end, I have a predefined list of fields I want to grab from a document. So I get a handle on the document, loop through this array of field names, put the values in an object, and send it back to the server. I'm sorry, I mean send it back to the front end. So let's take a look at that again in the front end here. So we have get data, and so here's our callback. Once we get the data from the server and verify that we're getting a success response, we're then taking the data, we're storing it in a local variable. So we're storing it in a variable inside of this object we have here, our client side car.rpc object. And we can go back to the browser here and interrogate that. So you can see here all of the data that we've loaded is being stored. Now, the reason why this is important is there's only one screen of data on the screen right now and only one screen of HTML. So coming back to the callback here. So where did you go? Get data. We put the data in the variable, and then we're calling this additional load method here. Now, this is a little confusing. I probably should have named this get data to be consistent with this get data call here. But so we're calling this load method, and all this does is reads the values out of that variable inside of the object and update all the fields on the page. The reason why this is important is when we come back here, when we go to a second screen, we're loading the HTML for that screen, but that HTML is not coming with any data. It's just HTML. So we're calling this load method again, from the getPage function because we need to supply values to those new HTML fields that have come from the back end and that we're painting the screen with. Okay, the last thing we want to do with the RPC control is submit a save request and save our information. So once again, I want to turn off HTTP to demonstrate the high availability, friendly nature of this. Okay, HTTP is down. Come in and load some more data. You can see even with HTTP being down, we made a request to get another screen of data and we successfully got the request back. So I'm just going to make an update to one of these screens. I'm going to hit save. You can see we saved our changes successfully. So let's take a look at that request. Our result we got back again is telling us what server where the request was fulfilled from, and our status success. We're not returning any other additional data at this time, but what we are sending. So if we go to, let's go back to our init function, and if you remember, we have our method that creates all the events on the page. So on here is a click event for the save button, which executes this client-side function. PC save, which is here, and this function gathers up the values from all the fields, executes an RPC call, RPC car save, which is here. You can see we're passing the doc ID as well as the fields. So I want to draw your attention to part of this request here. So you can see in our payload, we're submitting raw JSON. So I mentioned earlier that you can just send raw JSON. You do not have to convert your JSON to a string in order to send it to the server. So you can just send the raw JSON and everything gets processed nicely. And on the back side, here is our save. So get a handle on the document. Our field list, loop through it, update the document, save it, and send back the result. I'm going to refresh the page just to verify our save truly was successful. And here it is. So we get that value back from the server. Some important things to remember about the RPC control. Now, if the Domino server is fulfilling the request, and as long as your server-side code is returning a value, the result is going to be returned as JSON. However, we've had an instance on a public-facing site that is behind an F5 firewall / reverse proxy, where the F5 did not like something about the request, and it intercepted the request, and the request never got to the Domino server. And in that instance, the F5 sends a response back to the browser that is HTML. It's an HTML error page, and the JSON or the RPC control does not process an HTML response. So just something to keep in mind. Also, there's no specific error callback on the RPC control. You have to do the error handling yourself in your code. And finally, if as we just saw in the last part of the demo here, where we were saving a value back to the server, we had to pass the doc ID. So you can't rely on interrogating the URL for the doc ID on the server side. You have to get it on the client side and send that back as part of your request in the event that your request is bounced over to another server. The next thing I want to take a look at is the REST service control. And just like the remote service or RPC control, it's just a control you drag into the page where you want that to reside. There are several types of REST services that you can utilize within the REST service control, but I'm going to focus on the ones that I think are the most pertinent to the types of applications that we are talking about in this presentation. First is the Vue.json service. This is a control that we use extensively in our environment, especially if you've seen any of my presentations about the flexible view control or blog posts. That is, the Vue.json service is kind of like the backbone of that as far as retrieving the data. Next is the document.json service. Now, I actually have not used this part of the REST service control too much. However, with the shift that I feel is going on in how we are developing our applications and separating the front end from the back end, I think this is going to be an important part of that, because the document.json service, all it does is you provide a doc ID and it will return that document as JSON back to the client. And finally here, the custom REST service. The cool thing about the custom REST service is you have the ability to have separate functions for get or post. There's a couple others in there, but I think these are the primary ones that would be used. I kind of look at the custom REST service as more of like I think of it as almost like a structured X agent in a way, because you do have a lot of flexibility with what you can do in your get functions or your post functions. So I do see a lot of value there. Let's take a look at a demo now that uses some of these REST components. And this demo is going to be a little bit more complex, and it's going to be combining a couple different types of methods of doing things. So for starters, we're going to load an initial HTML template, and a little bit more on that in a moment as to what that means. Then we're going to get some data from a view, and then we're going to use a client-side framework library to take that data and insert it into the actual HTML of the page. Okay, here's what our page looks like. So for the view data, I'm tapping into my really large used car database. And this particular view is just showing all of the Chevrolet Tahoes for sale in Philadelphia, Pennsylvania. But let's take a look at the source. So when the page loads, the only source on the page is really just a table, but there's all the rows of data are not here yet. So what we do have though is this type of notation, which I'm using handlebars.js to actually build the table once I get the data. So let's take a look at how we're getting this. So it starts with code I found online from Sven Hasselback, and I feel like that this has really unlocked some possibility in building XPage applications to fit into this high availability narrative. So I do have a link to his to his blog post here, which goes into it. It involves using the NAPI classes in Domino, and what the code does is it allows you to read and write files from the web content folder in an NSF. Here is how we're using his code to do that. So back on our XPage, we have a before page load event, which is here, and we have another function inside of here called get HTML template. And what that HTML template function does is taps into this class. Okay, so we have a Java class over here, and as you can see, it's pretty simple. So not a lot of code here to be able to read files from the web content folder. So, and this is the file that we are reading. So you can see if we bounce back to our view source here, this part here matches up with what we see here. Now the next step in the process is to actually go out and get the data. So how are we doing that? So again, we have an init function down here inside of a script block. So once all of this content loads, this client-side function will execute. And that is over here. So the meat of this is a jQuery AJAX call. And here is the URL for our Vue.json service. So you can see it lives on an XPage called rest.xsp, and it has a path info of Tahoe. So if we come back out here and let's bring up DevTools and let's reload this. So here's our Vue data coming in. Okay, great. So we've got our Vue data using a REST service control. So once we successfully read that, now we can engage handlebars to actually build the table for us. So that's this bit down here. So I don't want to necessarily go into how to use handlebars. There's plenty of information out there on that. But so we loaded our initial template. We're getting a handle on that into a variable. And then we have to compile that. And here's where we're plugging in our data. So we have our result where the success callback, we're putting the data in a result variable, and then we're handing that into handlebars here. And then everything that compiles, it takes that HTML template, compiles it with the data, and then finally we're just dropping that full package back onto the page. And once that happens, the last thing we're doing is just kind of sprinkling a little sugar here to present the table with a nice UI using data tables. Now I want to add another layer to this demo. So what I want to have happen is when I click or double click one of these rows of data, I want some more detailed information to come up about that row. So when I do that, I'm bringing up a modal, and maybe theoretically I have the ability to edit some comments here and save those changes back, but we're keeping it pretty simple. But this modal HTML, so if we refresh the page, this modal HTML is nowhere to be found here. So what I've done in the past is I may have had a custom control with a rendered value on it, and by double clicking the row, it has done a partial refresh of a panel containing that custom control. And so then I'm getting into where I need to rely on the server to have a in-memory representation of that page in order for that to work properly. So again, we're kind of switching gears here, moving towards, not having any reliance. The client doesn't need to rely on the server at all. So let's take a look at how we're doing that. So we start out by calling an X agent to load the modal template. So we're using the code we have to read HTML documents out of the web content folder. And then we're executing a document JSON service REST call to get the individual information about that document. And finally, again, engaging handlebars to take that data and combine it with our template and give us a final product. Coming back to the init function here and into our data tables initialization, we're using the row callback within data tables to add that double click event here. So here's our call that's actually going out and getting that modal. So you can see in our client-side script, we have a function called getHTMLTemplate. We're passing it the template we want to get, but we're also passing it the callback that we want to execute after we get that template. So if we look at that here, again, a pretty simple function using jQuery Ajax. Here's the call to our X agent, and we're passing the template name as a parameter. And then again, if that is successful, we're executing the callback that gets passed in to the function. Let's take a look at that X agent. Again, some fairly simple code here. So now we're back on the server side of things, obviously. So we're calling our getHTMLTemplate function again that we used to get the initial view template. Now we're using it to get the modal as well. And again, that's back here, getHTMLTemplate. And let's take a look at the actual template within the web content folder that we're trying to get. It's car modal. Now, something interesting I want to point out back on our car table template is in our TR tag here, you can see we're setting a parameter. I call it data doc ID. So when I'm building a view, I like to have the doc ID for each document readily available. And I tend to put it in a data doc ID parameter. So you can see we're using the handlebars notation here. So that handlebars will take the UNID and stick it into this parameter for us. Now that we know where to get the doc ID for the document we want to display in the modal, we can come back over here, back in our init function, when we're setting up the row callback and the double click event. We're getting our template, and the callback we're executing after we get the HTML template is open modal. So we come down here, we're able to interrogate the row that we're double clicking to get the doc ID. And now we can execute the document JSON service. So again, we're using rest.xsp. Our REST service path info is getDoc. We're supplying it a doc ID. And then once we get that data back, we're just formatting some of the numbers a little bit, and then using handlebars again to put the packaged up HTML onto the page, and then finally actually showing the modal. So let's go back to the browser and reload. And then let's once again, for the last time, turn off HTTP. because again, the focus is on a high availability environment and being able to have our application continue to work if servers go down. So I've got my page loaded already, so I should be able to double click on a row and get data back. And there we go. So again, we only have a little bit of a delay there simply because the reverse proxy is recognizing that the primary server went down and now switching everything over to the other server. So with that, I am grossly over my time for this session. So where I want to go with this, there's actually a server-side version of handlebars that someone made called handlebars.java. And I see a lot of potential for that. So instead of having to make, potentially 2 REST service calls, one to get HTML and the second to get data, you can make one call and then everything can be packaged up on the server and sent back to the front end. So I see some potential there for having some custom page rendering, custom partial refresh rendering, and these are things that I definitely plan on experimenting with and playing with and blogging about. So stay tuned to xpage.me to potentially see what happens with that. One topic that I ran out of time for is to talk about creating your own state. So not using the XPages state, but creating your own state that can replicate between servers, a combination of on disk and scope variables. Others have talked about this and I think have experimented with it. I've experimented with it as well in my production application. So I think using all of these tools in conjunction with one another, you can do some really cool things. To recap everything we've talked about today. First, XPages, it has plenty of tools that allow us as developers to continue to build great applications. And by all means, utilize the server-side processing engine to load your page. And then once you do that, separate the front end from the back end. And by doing this type of development has benefits beyond high availability environments. So this is the way modern development is done. So it's going to make it easier to work as a team. It's going to make it easier to troubleshoot problems in your application. It probably makes it easier to deal with source control. And then, quite frankly, as a developer, you become more marketable when you can exhibit specific front-end and/or back-end skills. Thank you to everybody who took the time to watch this presentation. If you have any questions, you can drop me a line on the CollabSphere Discord channel, on Twitter, or leave a comment on my blog. Finally, a gigantic thank you to Richard Moy and everyone else who helped put CollabSphere together, and of course the sponsors who generously donate to help make this conference available every year. It really is, year in, year out, is a great conference with great presentations. So big thanks there.